you have the periodic table right here. So if you have it in front of you, what I would like you to do is, I would like you to pay attention or label your periodic table this way. Number one, these numbers right here on the side, those are the period numbers. That's your n. So this is n equals 1. I know it's very small, but because, let me make this bigger. Okay, so I'm going to try to write as small as possible, but that's your n. So that's n equals 1. That's n equals 2, 3, that's 4, that's 5, 6, and that's 7. Okay, so this is your energy level. That's the period number. All right, now here's what you want to do. Next thing you want to do is, if you have a highlighter or anything to divide, what you want to do is you want to divide the periodic table into sections. Okay. And I'm going to color this right here. I'm going to do my best coloring it, but if it doesn't work, I know it's going to take me a long time, so I'm probably just going to color this. But this is what you want to do is you want to say that this is the S area. This is the S block right here. And by the way, this is shown in your lecture notes. You can, if you would like, you can see it. It's right here. It's right here, all of it. But to make it interesting here, so let's go now to this area right here. This area, and I'm just going to color a little bit here. Actually, maybe not a good idea. All right, so let me just say this is the D block right here. And then all of this here, all of this is the P block, P, meaning your electron configuration is going to end with P. And then finally down here, this is the F block right here. All of these are the F. Okay, S, P, D, and F. What do I mean by this? Well, meaning that your electron configuration always going to end with these, the S, if you have an element from here. If you have an element from this one, the last one is going to end with a D, end with a B, P, I'm sorry. And then this one's going to end with an F. You're going to see that. So I don't want to talk too much about this because this is very practical. And just pay attention. Is that, again, this is the 2. So that means you have a 2S and you have a 2P. 3S and then a 3P. Now, when it comes to the D, remember what I said to you, n minus 1, n minus 1. So that means you have to subtract 1 from this 4. So your D starts with a 3. This one starts with a 4. This one starts with a 5. For your F, remember what I said to you, your F is minus 2. So that means, okay, that means that your F, remember your F begins after 57 here, right here. Your F is going to be 4, because again, you have an F at the 4th energy level. So this is going to be 4F. This is going to be 5F. Okay, let's begin. So let's begin with the simplest element, which is hydrogen. So here's how I do hydrogen. Okay. Now be prepared to write big. I know I left enough space, so you can write space. Keep writing in underneath this here. You want to increase the space, that's fine. But I'm going to work here because I want to have the periodic table in front of me and show you. So if I have H, all I have to do is look right there. Okay, very well. So in H, I start with this number right here. That's a 1. What area is this? S. I have 1 electron, so I just write 1. But there's a quick and easy method for you to kind of latch on. This right here, okay, is 1 box. So that 1 box means 1 electron. Here it is. So it's 1s1. You're done. If you do helium, start with the 1. Okay, now helium is there, so you might be thinking that, okay, helium is in the P block. No, the P only includes anything below, again, this line. So actually the HE is actually part of these. It's still, because it's in the first energy level. Okay, so what I like to do sometimes is just bring the HE here. I'll just write it here. But I know it's a noble gas, so yes, you still have to use it, but I'm just going to use it for this purpose. So here it is, 1. This is the S area. Maybe I can highlight this to make sure that you know that, oops, it's not, that's the S area. Okay. That's 1S, that's the S area. And then how many boxes? 1, 2, or 1 down, 2. Here it is, 1s2. What does that mean to us? This means to us that we have 2 electrons in the first energy level, and that orbital is an s orbital. And that is consistent with with quantum mechanics, that the first energy level has 1 sub energy level, and that's called the s. That's it. Lithium. Over here. Remember what we said. We said we have to follow something called the building up principle. You have to start from scratch. You cannot just jump to lithium and say, oh, okay, here it is, 2s, and then, oh, there's a 3, 2s3. Well, number one, that violates, S can only take 2 electrons. So you can't put 3 electrons in the in S. And plus, okay, so you say, well, what do I do? Okay, 2s1. Okay, if you say 2s1, you're partially right, but the problem is you don't account for all 3 electrons. Well, if I say 2s1, then I'm missing 2 more electrons. Where do you think those are? Those are, yes, in here. So imagine lithium is like helium, has the same electronic structure, almost the same electronic structure, except it has 1 more, and that's in the 2s. So look, here is just to make it more practical. You say 1, start from beginning, from scratch. You say 1, this is the S area. 2 boxes. Then I go down here. 2, that's still the S area. And I have 1 box for lithium, 2s1. Okay. Now, this is your core shell, which corresponds to core electrons. This one, the outer one, is called your valence shell, and therefore you have valence electrons. And this one obviously has 2 core electrons, Here they are, 2. And this one has 1. So you have 2, oh, sorry, 1 bivalence electron. So valence is outermost, on the outermost. So if you were to picture this really quick, I have a nucleus. Here it is, positive charge. And then I have 2 shells. Here's the n equals 1 shell. This is the n equals 2. Okay, and the n equals 1. Here's the 1. Here it is. I have only one shell, one subshell, and I have 2 electrons. Here they are. 1. Okay, let me use a different color here so you can see that. I have 2 electrons. Here's 1. There's 2. And then I have in the valence shell, that's 2. I have 1 more. That's lithium right there. And if you have your nucleus, it has 3 protons, as we said. So that's how you should think of it. So again, this is the core. The one on the outside is called the valence. Okay, how do I know it's on the outside? Well, it's the one with the largest number, and however many subshells are in there. Okay, so let's do more. Let's now jump to boron. Okay. Very well. So you have boron here. Right here. Okay. Start from the beginning. Start from the beginning. Okay. 1 S area. How many boxes? 2. 1 S2. Then I go now there. 2. See, I go from 1, or you can see that HE or that one, it doesn't matter. I'm done. I filled that shell. Now I'm going down here. Okay. Why can't we jump to boron? Well, how can you jump from helium to boron? That's 2 electrons. This is 5. So you have to go. That's why it's called the building up. The moment you forget the principle of the building up principle, that's when you, again, start making mistakes. So we say 1s2. Then we begin here. 2. Okay, that's the second shell. 2. I have what area is here? The S. Okay. Now, in order for me to get to boron, I have to go through lithium and beryllium. So I say 2s, how many boxes? 2, which is consistent with the S only taking 2 electrons. That's why you see 2 boxes here. And then when you get to this one, you say 2, still a 2. Which area is this? P. Okay. Start counting. How many boxes is B? Just 1. 2p1. Okay. This is also consistent with the energies of the orbitals here. So the S fills first, then the P. And that accounts for the 5 valence, the 5 electrons. Here's 2 plus 2 plus 1 is 5. Okay. Which one is core? Which one is valence? Well, just look at the number. I have a 2, so 2 is bigger than 1. So both of these are valence